The energy required for a phase change is the enthalpy of that phase change times the amount of substance that we have. We may be in a situation where we have an enthalpy of vaporization in terms of the number of moles, an energy per mole, and we have the number of moles of that substance, and then it would be really easy to use this equation. Maybe we are given the amount of a substance in grams, and we have the mass. Then we would need to match that with an enthalpy in terms of grams. If the units of our enthalpy and our actual amount don't match up, then we're going to have to convert one so that they do. But let's see, what do we have here? We have a value for the enthalpy of vaporization of ammonia at 23 kilojoules per mole. Let's see, do we have the amount of ammonia in moles instead of grams? If so, our units match up and we're good to go. Yes, we do, 4.5 moles. So we can use the per mole delta H and our number of moles N. And we can see how the moles cancels here to give us kilojoules. You might say though, hey, this is a condensation process. Why are we using the heat of vaporization? Well, this is, it's the magnitude is the same. It's just, the process in reverse. So the same amount of energy goes into the ammonia when it evaporates as goes out when it condenses. Here's a bonus question for you. This is kind of like the hidden question at the end of the video. Did you guys, has anybody ever like had a CD with music on it and there's a hidden track at the end? Like there's 10 minutes of silence and then an extra song that isn't advertised. Does anybody experience that anymore? Because that used to be a fun thing. There was a Beck CD with a hidden song at the end. But anyway, the bonus question is, what is the energy released when 34 grams of ammonia freezes? Now, when we are talking about freezing or melting, we have to use the enthalpy of fusion. So we are going to need to find that value. And this, the enthalpy of fusion is the second column in our chart. Here's the second column over here, 5.6 kilojoules per mole. And we need to multiply that by the number of moles we have, but we're given grams. Oh no, we're going to have to convert. What is the molar mass of NH3? Nitrogen weighs 14. We got 3 hydrogens each at 1. 14 plus 3 is 17. The molar mass is 17. I'm putting it down here, 17 grams, because the whole point of this operation is to cancel grams. And that's 17 grams per mole. So we're essentially doing 34 divided by 17. We get 2 moles. And that's what we can put in for N. And there's your answer. Here's our problem here. The enthalpy of sublimation, that just means how much energy does it take per gram to change the phase from solid directly to gas. So this process here, that's exactly what sublimation is. So if you know what enthalpy of sublimation is, that it's just the energy per gram to sublime something, then this is pretty easy. We just do energy per mass. Maybe you look up an equation for the heat of sublimation and you found something like this. Then you can simply rearrange it to solve for delta H. But this one is pretty straightforward. We just plug in our numbers. And paying attention to our units, we get a joules per gram here. Oftentimes, heat is expressed in kilojoules, so we could shift our decimal point 3 places to do a kilojoule per gram number here.